Welcome to episode 59 of Science with Miss Steph. Today we explore how temperature can change our results in the storm in a cup reaction. Thank you for watching and stay tuned. Start recording. Start streaming. Hi, and good afternoon. Welcome to Saturday Science with Miss Steph. This is the 59th episode of Science with Miss Steph, folks. We are live on Instagram. And as soon as I press this button, go live. Hey, we are live on, let's get it going, live on Facebook. Yes, but we are doing our water unit. Last week, we talked about all the different things that water can do. In particular, last week, we talked about how water can separate things, or rather, can be used as a part of the components of a chromatography setup, right? We separated the colors in marker. And yes, you can use food coloring and all kinds of other components to test that out, to try it at home. Once again, that was episode 58, chromatography art, because we took that piece of chromatography, y'all, or rather pieces, multiple pieces of our chromatography strips, and we actually turned it into a wonderful and fun art piece. And so I want to encourage you to make sure that not only are you watching us live and you're watching and following on Facebook, but that you're definitely subscribing to the YouTube channel. Yes, so that you're able to go back and check out all these different things and all these really fun activities, and make sure that you're compounding your learning. But yes, today, welcome to Science with Miss Steph, episode 59. Time is passing, people. We're doing episode 59, and we are continuing our water conversation and the power of water and the different fabulous experiments and activities we can do with water. Today's particular experiment is really going to be focused on how the behavior of water and how the behavior of any type of substance actually can be affected by its temperature. And so, as you know, Storm in a Cup, it's one of my favorite activities to do. I don't call it an experiment because I essentially know what's going to happen, right? An experiment is something to where you're testing a variable. Well, guess what? Today, we are going to actually throw in a variable with that particular activity, now turning it into an experiment. And our variable is going to be the water temperature. We are going to change the temperature of the water for this, my friends, my darlings, my scientists, and find out how the water temperature, or whether or not the water temperature makes a difference. Maybe it doesn't. What do you think? Do you think that changing the temperature of the water in our storm in a cup activity or demonstration will make a difference? Do you think it will change? Do you think we'll be able to make snow looking stuff if I use ice water? Do you think that the steam will somehow impact how things react if I use hot water, if I use boiling hot water, or rather water that I boiled and now is probably cooled down a little bit, but still is technically hot water? I mean, what do you think will happen doing a multi-temperature storm in the cup experience slash experiment today? So, okay. The materials for this activity tend to be pretty simple. This is going to get a bit expanded because we are, like I said, using 3 different temperatures of water for this, folks. We're going to use a hot water that has been brought to a boil. Okay, and I know it's been brought to a boil because I saw steam coming out of my tea kettle. Okay, water that's just out of the tap. Okay, and we're calling it room temperature water. Water that is at room temperature. It's been sitting out and it has been able to normalize with the temperature in the room. Okay. Also, wow, what is about this time of day that things just like to happen? Okay, and also we're using ice water. So I got some ice, as you see, quite a bit of ice, and our water is going to be just above freezing, obviously, the water portion of it, the liquid portion of it, and then of course we have solid water. Right? Yeah. All right, so let's do our hot water first. Why am I doing the hot water first? First of all, as far as the temperature, right? I know that if I do this first, this one is going to be the closest to the temperature that I started it out with, right? Like, I mean, this came to a boil. I don't want this to sit and then normalize and then come to room temperature because then that, right, like kind of defeats the purpose of doing different temperature levels. Once again, thank you for joining me. I'm Miss Steph, and today we're having a great time with one of our oldies but goodies, Storm and a Cup, and we're doing Storm and a Cup at 3 different temperatures and finding out whether or not that matters, whether or not that does anything. So your other materials that you'll need, I presented you with 3 materials, right? They're all the same substance, but they were at different temperatures, right? We need hot water, room temperature water, okay, and ice water. You notice you need 2 cups per water temperature, so that's a total of 6 cups. And then we need some shaving cream. Yes, it does need to be shaving cream. It cannot be shaving gel or whatever and whatnot. It needs to be shaving cream. Okay. And food coloring. Even though water is clear for whatever reason, we as a society or whatever, right, typically associate blue with water. Okay. So I'm just going to use blue. It has nothing to do with whether or not, I mean, there's nothing in particular about the blue. Just keep in mind that blue food coloring does typically stain the worst or for the longest. So just be mindful and be careful. Okay. Also, I'm working with hot water. So, yes, for my younger friends, my younger scientists, be very careful with your hot water. All right. So, I have it labeled. I've got hot water. This is my source of water, my water source. And I've got my cup. And again, that's been pre-labeled. My hot water storm. So I'm going to put about 3/4 of my hot water inside of my storm cup. Again, we're on today, continuing our water adventure. And today we're looking at what difference does it make? What does it matter if I change the temperature of the water when I'm doing a specific activity? In particular, our Storm in a Cup activity. We usually use the Storm in a Cup activity with various age groups, right? Talking about the water cycle. Okay. And we'll do a little water cycle refresher once I get this first one down. Okay. We usually use it, right, to talk about the water cycle. And normally I use room temperature or neutrally temperatured water. Okay, it's neither hot nor cold, typically. Today, I'm using 3 different temperatures of water. Okay, so the first thing I want you to notice, okay, is just how the shaving cream, which as we know is our cloud, which it doubles as our cloud in this water cycle model. Okay, like I said, we normally use this activity to teach about the water cycle. Today I'm teaching about water temperature and how it can affect the 2, 3, 4. How can it affect or impact an activity? And I'm starting with my hot water. Remember, be very careful with your hot water, especially like I said, my younger friends. Hi. Okay. And so now I've already done my food coloring on top of my cloud. Again, this is a model of the water cycle. Okay. And let's see what happens with my storm. Let's see what occurs with it being over hot water and my pouring hot water into my cup. Okay. So as you can see, it comes right down. All right. Hey, Vaughn. All right. So we've got our food coloring, and I only poured just a touch bit of water in. I didn't have to pour very much, right? And I already started to get movement with my food coloring. And another thing that you can see is it's almost suspended. My blue is like suspended in animation there almost, right? My blue is really just kind of sitting there, giving me this nice swirl, beautiful shape happening. Let's pour a little bit more water. And once again, I'm doing the hot water first because I want to use it as close to its true temperature, right? As close to the temperature that it was when it came directly out of my tea kettle. I don't want to give it a chance to cool off and become room temperature water because I'm going to test room temperature water shortly. All right, so that's what happens with my hot water. It is warm to the touch, okay? Very warm to the touch. As you notice, my shaving cream is just floating on top of there. There's no movement of the shaving cream, okay? And my food coloring very just gently comes down and it kind of gives me this gentle swirl situation, okay? So I'm putting that to the side. Now, let's try it with our room temperature. Once again, that's the temperature that I typically use with this activity. And we are learning today about water and how the temperature of the water may or may not, we're seeing, change our results, change what happens with our reaction. Okay. Once again, 3/4, I'm using about 3/4 of the room temperature water, putting it in our reaction cup. Okay. Putting it in what I have labeled as our storm cup, taking my shaving cream. Yes, yes, yes. Right. Putting it on top. Okay. Shaving cream is something that's a little hard to control, right? And so I'm not getting an exact replica each time, simply because trying to make shaving cream look exactly alike is hard to do in a way that would allow you all to be able to see what I'm doing. But we've got that. The shaving cream is sitting on top. It's still floating. Okay. Going to do 5 drops of the food coloring on top of the shaving cream, not inside of the water, just on top of the shaving cream. Remember, this is a model of the water cycle, and the shaving cream is our cloud, is our condensation. Okay, you see that there? Fabulous, fabulous. So now I'll pour, I'll pour my room temperature water on top, and let's see what happens. Okay. Same amount as I did last time, just a little bit. And you notice the room temperature water doesn't quite come through my cloud as easily. Okay, my room temperature water doesn't come down and give me this storm. I'm going to need to add more water when it comes to room temperature water. So the temperature, as we see, seems to make an impact. And again, there I added more water, and all I got was just kind of this little bit of thing happening, just a little. It didn't give me a full storm. It's not coming all the way down. Okay. Whereas if I pour some more, Now it's coming down. But again, it's kind of almost making my cloud layer thicker instead of really giving me the rain situation that we were able to get with our other one. And again, I had to pour more, and then the water the food coloring, see, it's coming down. Now it's coming down. But right, it's still not coming all the way down. Whereas with my hot water, let me remind you, the hot water, you see that blue? This is my hot and this is my room temperature. The blue is having more trouble coming down in the room temperature storm. All right, so let's find out what happens with my ice water. With my ice water. And as I get my materials ready to do the ice water storm in a cup demonstration, let's review the steps of the water cycle. This is a cycle that happens on our planet constantly. It's constantly going. Okay. So you get this evaporation step. The water changes from liquid to gas, and then it condenses in cloud form. Okay. And then eventually, at some point, when enough water gets up there and the clouds are full, okay, and the clouds are no longer able to then hold the water that is in there, then it falls in the form of precipitation, okay? And we know that precipitation is literally just water falling from the sky. So it could be any version of water. It's not only rain, it's not only snow, it's rain, snow, sleet, hail. Water falling from the sky, precipitation. And then it falls down and it gets collected in some way. And then that whole cycle starts back up again. Evaporation, condensation, precipitation, collection, people, okay? And of course, runoff happens once, while the water is falling down, and you get runoff coming down mountains and so on and so forth. All right. So now let's try with our ice water. Ice water. What do we think? Do we think that the ice water will be different? Let's take a beat. Let's think about, let's make our prediction, right? Should the ice water be different based on our two samples? Hot water, which by the way is still quite warm, still significantly warmer than my room temperature water. Okay? Let's find out. Again, let's look at it very quickly. Okay? I want to make sure that the procedure is consistent with how I did the other samples. This water sample, folks. Welcome to Science with Miss Steph, people. We are doing our classic Storm the Cup activity, but we have changed one variable. We have changed the temperature of the water that I'm using. Got my shaving cream. At the bottom, I've got ice water, including, some ice there. Okay, you can imagine that this is our cloud situation. So now let's pour, and I'm going to pour again on top of one of my food coloring dots. Okay. Very little. Okay. So my my food coloring, as you can see, is kind of stuck. It is not coming down into the other layer. Okay. It's stuck in my ice. It's not coming down. Okay. There, Facebook. Okay. So we have hot water, room temperature water, and ice water. There's a distinct difference. So to the degree that you would say that rain, it's easier to get rain okay, when it's warm or when it's a little on the hot side, okay? The clouds release their water more easily, okay? Based on this, now we would need to cross-check things, right? We would need to double-check our science and check into, the weather, um, meteorologists, right, to double check to find out if that's what happens in real life as far as in those situations. But this is what happens in our demonstration. If it's hot, it's easier. Okay? It's lukewarm, it will rain, but you need more volume of water. Okay? This, it's kind of getting stuck a little bit. Okay? Stuck. So what I'm going to do is go across. I'll actually add a few more drops of food coloring on the very tippy top of all of them. Okay. And we're just going to have some fun, right? So we did the science of it. I did the controlled version of it. Do. Okay. And now I'm going to just have some fun because, like, that's just how I feel about science. It's fun. So this water is still a bit warm. Of course, when it's en masse, it's easy. It keeps its heat, better. Like we all know that uh, temperature is more easily kept when you have larger quantities of something. Okay, so pour. All right, and we've got that coming down. You should really be able to, even on Instagram, you can see how that just comes right down. I'm going to put it up close. You see that beautiful blue coming down. It's fabulous. All right, let's leave that there so you can see. I'm going to take my hot water and put it up front so that it doesn't obscure the view. All right, so then now let's see if we can get it to really rain here in this cup. And you see, it really takes quite a bit for it to release, not to just come down, but for it to release and come all the way down to what we would call the ground. Y'all saw how much water I had to put in there? And it's getting released from the clouds. Okay, we're getting this layer of blue, but for it to come all the way down is going to take a little time. Okay. By the time the video is over, I imagine it'll come all the way down. Okay. But I'm getting that it did this release, but didn't come all the way down. Whereas this one, it comes all the way down. All right. So now you see our blue is still trapped, quote unquote, kind of trapped in our ice layer, which kind of sort of makes sense, right? So we've got our different stages. So in the beginning, I didn't quite pose it as a question. Well, actually, I did. In the beginning, I said, "Hey, are we going to get a different result essentially because the water temperatures are different?" I would say our answer is yes, right? Isn't it? Did we get some different results as far as the timing, as far as how long it took, and for how much water it needed before we would get this rain or this precipitation step to happen? Because look, this is still trapped. Our blue is still trapped. It's coming down a little bit now that I've given it some agitation. Okay. So is there a difference if I use hot water, room temperature water, or ice water for the storm in a cup activity? I would say absolutely. Is there a difference if I were to use different shaving creams and so on and so forth? Slightly, slightly, but it's not this big of a difference. Okay. So, my dear scientists, thank you so much for joining me for Science with Miss Steph. We had a great time learning about the water cycle, evaporation, condensation, precipitation, and collection. We had an awesome time changing the temperature, turning our water cycle activity, our storm in a cup classic activity, into an actual experiment by changing one variable. Okay, can only be an experiment if you only change one variable, folks. One. We can't just be changing everything. Okay. Thank you for watching this exciting episode of Science with Miss Steph. Make sure that you like, share, and subscribe.